here. So good afternoon, everyone. So in this morning session, we have seen that how to change the boundary condition like hello, am I audible? Hello.
Yes, sir.
Okay. So I will share the software screen here. Okay. So let me know is visible here. Software screen is visible. Hello. Hello, everyone.
Yes, sir.
Yes.
Quickly give me reply so that I can proceed further. Okay. ऋषिकेश
Yes, sir.
हा येते ना ऐकू
Yes, sir.
Okay. So how is my voice quality? Is it audible properly?
Yes, sir.
Okay. So I will start with this roll cage analysis. I'll show you here the roll cage structure is there. So you can check out this is the front part of the roll cage and the distance is here around 400 and this one is 300 square is there. This to this distance is around 600. Then this to this is a 500. This to this is a 300. Okay. So this is what the roll cage model and that we have to analyze by using 1D analysis. Okay. So now I'll start with nodes. So go to the geometry, create the nodes with X, Y, Z coordinates. So first node is 0, 0, 0. Okay. So create it here. So that will be displayed. Then second 300 square we have to prepare. So create it that one. So you will get that. Then 300 by 300 because the coordinate y coordinate is 300 now. 300 300 create display. So here it is 0 0. Then this one 300 0. This one 300 300. And then this coordinate will be 0 300, right? So I will put it 0 300. Create it. Okay. So this is what the front portion of the roll cage. So I will just rotate it, press Control button, then left click and rotate it. For zoom in, zoom out, you have to press the Control button and this scroll. You have to do the scroll of the mouse button. So you can just rotate it by Control button and left click. Zoom in, zoom out by scroll button. Control button you need to press it. And then if you want to shift or if you want to pan it, then you can use the right button of the mouse and control button from the keyboard. Okay, so this is the front portion of the roll cage, and that I'm going to connect it. But before that, I want to copy these nodes and translate in the right direction, this direction. Getting? So there is a one tool that you have to use, that is translate. And all the tools you will get in this here, editing tools, you will get in the tool button. So there are different buttons like translate, rotate, scale, reflect, project. So these are the some editing tools are there. And then this is a Z direction, this is the XY direction. So length is along Z direction we are going to consider. Okay. So how we can translate it? Go to the translate button, and what we have to translate, that node. There are different translates. You can translate the elements, component, line, but we have to translate the nodes. Getting? So you have to select the nodes. Either you can select by clicking or shift button and drag the mouse and select all. Okay, by pressing the left key, left button. Okay, so that are selected, and I have to translate in Z direction, right? Z direction, in negative Z direction. Okay, so and the distance is, we will keep this distance 400. Okay, so 400, I will put it there, 400. Getting? Then translate it, but before translating, you have to copy the nodes. So make it duplicate. Click on the node and duplicate. If you not do the duplicate, then as it is, that nodes are going to be translated. It will not create the duplicate nodes. So translate positive, this would be translated in this direction. We don't want, we want in negative direction. So translate negative. So total 8 nodes will be created. Getting? And this is the front portion of the roll cage. So how we can connect it? By line. So go to the geometry, then lines, and here click on the this part. Okay, then connect it this to this and press the middle scroll button, this to this. You can create like this, or maybe you can use short key, that scroll button, press. Okay, press the scroll button. So this is the front part, then this to this.
हॅलो सर.
Ha, yes.
सर ते आपण नंतरचं जे नोड घेतलं का नाही, समजा जर ते सेम म्हणजे सेम लाईन मध्ये नसतील तर, म्हणजे मधला जो मेन रोल हुप आहे तो मोठा असला तर?
मधला काय म्हणतोयस?
आता जे तुम्ही कनेक्ट करताय ना, जी लाईन आता लास्ट कनेक्ट केला एकदम, आता ते नोड, तो जो नोड घेतला तो पहिल्या नोडच्या लाईनीतच आहे. फर्स्टला आपण जे 4 नोड घेतले त्या लाईनीतच आहे.
बरोबर
पण
आहे, एकाच
पण जर त्या लाईनीत नसेल तर सर मग कसं घ्यायचं?
I'll show you. There are some options. I'll show you in this one. Okay. This to this, I'll show you. You check out here first. Okay. This one, you have to give the coordinates. Coordinates are important. Getting? You can set the 0, 0, 0 anywhere and take a distance x coordinate and y coordinate. Suppose if I want here. Okay. So here it is a 0, 0, right? So x coordinate is my, let us take 100 and y coordinate is 500. Then it will be created here. Okay, I'll show you.
Yes sir, got it sir.
Okay. Then next point is this to this to this to this. Okay, then this to this to this. Okay, so these are all are joined for this particular front part of the roll cage. So you can see this part I have created here. Okay, now this to this is equal to around 600. Okay, so I will take the 600. Okay, so again I have to go to the translate tools, translate, select the nodes by using shift and scroll button. Sorry, not scroll button, left click, drag it. So pick up all the nodes simultaneously. Then here I have to put 600. Then you need to make it duplicate. If you don't make it duplicate, look at here, it will move like this. So that I don't want. So I will plus it, make the duplicate, and then go to the minus translate, because minus, why I am taking minus here, Z is in this direction. So I have to translate these nodes in this direction, negative Z. That's why I'm using here minus translate. So that would be duplicated and translated. Getting? Now, this is also I'm going to translate this part. This part is I'm going to translate this one, these two nodes in upward direction. Translate, select the nodes, this and this. Okay. I want to translate in upward direction, means axis should be y axis. So select here y axis, and the distance I will put here 250. Okay, 250, and then translate in positive y. Before that, make it duplicate and then translate it. So that is going to be translated. Now again go to the geometry line, select the this part to this part, this to this one, this to this one. Okay, same you have to join this to this. Okay, then this to this. Okay, then this to this, this to this, this to this. Okay, so this part is prepared. This one I have to use this one half circle over there. For drawing this half circle, it is required to take the middle node. Okay, so what I will do, I have to use the node between, geometry, distance, select the two nodes, this to this. The distance is 300. I want middle node, make it here node between. So middle node is created over there, temporary node. Now I have to draw the half circle over there. So go to the geometry line, and here you will get the circle. Okay, so arc, center, and radius circle. Click on that. So here along the Z axis, I have to rotate the circle. Okay, so that's why here you need to select the Z axis. If you take the Y axis, that would be like this, means in the top view mode. Okay, top view mode, the circle. And then if it is this one, then it would be side view mode. And let us consider this one. Okay, along the Z axis, I have to draw this circle along the Z axis. The axis should be passing through that midpoint of the circle. That is what required. Okay, so Z axis, radius is equal to 150 because this is a 300 just we have measured, and the angle of the half circle is 180. So that we have to do. Then node we need to select, middle node need to select and create. So that circle is created. Okay, now next part I have to create this part, this. So this to this distance is a 500. Let us consider 500. Okay, so I will use now again translate button. Here axis should be Z axis because I have to rotate in translate in Z axis. Then select the nodes, shift button. Okay, Okay, then duplicate, make it duplicate, and here distance should be 500 and translate in -z. Okay, so that is translated. Go to the return geometry line, then select this line option and join it. While joining, join first front top surface here. Okay, then slowly you have to close the loops. Do not join randomly. So this part is completed, and then finally you can complete the bottom part. Do not join this line first, then second line like this. Do not do like this. Okay. Now some of the supports we require to add this to this, this to this, this to this, this to this, then this part to this part, this part to this part. So I have to join like this. So I will join lines from this to this, this to this. Okay, then I have to give the support from this point to this point, from this point to this point. Then I have to join also this point to this point and this node to this. Getting? Then finally this one, this to this, and this point to this point. Okay, and then also you can create the support here in this way. So I have to create the node between into that one. So go to the geometry and go to the nodes, not nodes, geometry, distances from this point to this point. Sorry, distances this point to this point, and we have to choose here node between. So node is created in between that. So this distance tool is used to basically for measure the distance between two nodes, 2 points, and create the node in between that. Getting? Now geometry, and then go to the line, select this point to this point, this point to this point, this point to this point, this point to this point. So here with my roll cage structure is I have created. So this is a component part. The modeling part is completed here. If you have any query, then you can discuss. Otherwise, I will move to the next part of this particular roll cage. So same way, whatever I have used the different tools for the roll cage, same tools you can use for stress analysis, right? Or maybe any type of analysis, 1D analysis. Okay. Yes, shall we move to the next part? Or if you do you have any query, then you can free to ask if you have any query. Yes. Am I audible, na?
Yes, sir.
Okay, Udesh. Then next part is what we have to do the analysis of this roll cage structure. But before going to analysis, we need to check out whether that are connected properly or not by doing meshing. So first of all, you have to go to the material section. Same steps we have to repeat it again. MPCLL, MHPCLL. So go to the material, put it there steel. So I will use now here steel. Then change the color. Then type of isotropic, card image mat 1. Create edit. Do not forget to create edit. And give the Young's modulus, Poisson's ratio, and the density, right? So here all the properties required to on, then go to the return, material is created. Whatever the component we have created, that is shown in here, and I'll change the color of that component, so that would be better. So it is looking better. So I have changed here color. Now next part, MMH hyperbeam. So you will get this one 1D hyperbeam. So basically this hyperbeam, this particular roll cage structure basically completed with, or maybe prepared with, what we can say, that hollow pipe, right? Hollow pipe. So that I will use thin walled tube here, thin walled tube. Okay, thin walled tube, and then create it here. And I will use here outer radius 12.5, and the inner radius I will use the 11. So the thickness will be 1.5. Okay, and then I will go to the model view. So one more thing is that remaining, I think, in the model, this part is remaining, this. So that you have to arrange it. So go to the geometry line, and this to this we have to join, and this part to this part we have to join. Okay, so that will be that this part will be supported by this one. Okay, now next part, hyperbeam we have created MHP. Go to the property part, properties, select here roll cage property, roll cage property, select the color, then type is 1D card image. We are going to use the beam element over there because we require 6 degrees of freedom. So I will use the beam element over there, P beam, then material steel, beam section, tube section. Okay, then create edit. So that properties are created here. Go to the return. Then next part is that MHPC component already we have created. So you have to just update the component. Okay, instead of creating component, you have to just update the component. So here you can update the Atto1 component, but I can change the name of the here component, rename. So I will use here roll cage. Okay, roll cage. I will use the roll cage. Then instead of creating component, you have to update the component. In basically in the last some problems, what we have done that we have created component here, and in the component itself we have generated the, or we have developed the geometry here. But in this problem or in this analysis, we have created component first here in the geometry part, and then we are assigning that geometry to this component. Okay, so that's why it is required to go for the update component, select the roll cage, means this roll cage is assigned to this component. Okay, then color as it is card no image, no card image. Property we need to change. Here you have to click. Okay, इथं click करावं लागतं, then and then only that will be on. Then double click, roll prop. So P beam steel mat 1 will be assigned to this component, and then update. So here you will get the message component are updated. So that message you can get it here. Okay, then MHPC component part is over here. Okay, now next part is that what MHPCL load collector. So load collector, in the load collector, we are not going to do the static structural or linear static analysis for this one. Before that, load collector, we have to use the meshing here, because we have not used the elements here. We have used lines are here. So that line should be converted into element. So that points and lines are used. So that, and these are the temporary nodes, not final nodes. so that we have to mesh it this. Okay, so what I'm going to do it here, that you have to go to the 1D and the line mesh. Okay, so line mesh, select all the lines. You can select line like this, or maybe you can use the shift button and select all the lines simultaneously. Click, drag mouse and select. Okay, shift button you need to press. Then while selecting you have to use the shift button, and while rotating, pan, you have to put the control button. Okay, now these lines are selected. Element size I will keep 10 element size, sorry, 10 element size. Here you have to select the bar 2 because beam element you have to select, you have selected. Here property, double click, and roll cage property you have to assign. Then you can keep as it is auto, and then you require to mesh it. Okay, then return. Okay, so you can check out by 3D representation whether that are going to be this one. So if you observe, some of the lines are failed to create the mesh, and if you observe here, this is a meshing. What we have done, we have created small this part, and if I check the small single element, how we can select. So go to the mask, here mask option is there, mask, select this one element and mask and reverse all. So you can check out the single element pipe structure, how that structure is there. So you can check out element, this one is a single element. Okay, so I will do unmask all. This is not required to do, just for your information I'm showing you how the elements are been created, and how we can check out that one. So unmask all, I will do unmask all. When I do unmask all, that everything will be come again. Mask and unmask means it is for displaying and non-displaying. Okay, so this option is here, mask. Getting? So what I want to say it here, that this part, the elements are not properly generated because on these lines. Why it is not generated? Because of the orientation, element orientation. Yesterday we have seen the element orientation. If the orientation axis is changed, then it could be possible to generate the elements here. Okay. So by pressing control button and mouse keys, you can play with this component. Okay, now I have to create the meshing over there properly. Elements need to be created over there. So I will again go to the traditional representation. But before that, let me select the 3D representation, and I have to go for this 1D, then bars, and we have to update the element. So how we can update the elements? I can select some elements on the each line. Okay, and I will change the representation to traditional one. So you can check out white colors are there, that lines need to be updated. But what I will do, it is required to select this every line, one line, second line, third line, and fourth line. So along Z direction, the problem is occurred. So what I will do, I will update the elements. Okay, so update the elements with the orientation axis. So for updating, I can select step by step, but it is better. I will try with the selection, all selection. So everything will be created, and here orientation axis need to change as a y axis. Property, roll cage properties, element type, C beam. This is very important step. Otherwise, you will not get the proper result. Okay. Then this one, and then update. So it will ask what are the options are there that should be assigned to all the elements and then update. And if you go for the 3D representation, so all the elements are updated here. You can check out. Okay, so this is my roll cage structure is created properly. Getting point? So here only orientation axis is changed. Otherwise, everything is same here. Now go to the return. So what I have done, all the MHPCL load collector. So I'm going to go for the load collector. So here load collector, I am going to consider this particular chassis for normal mode analysis, means modal analysis. Why? Because we directly cannot go for the static structural analysis. First of all, we have to check out the frequency or natural frequency, pre-condition, pre analysis for this particular type of structure. And we have to check out whether that whatever the elements we have created that are connected properly or not connected properly. So if it is not connected properly, then that roll cage will break at any mode of that particular pre analysis. So it is better for you have to use the this pre analysis for before going for other analysis. Okay, so for that I have to go for the load collector, and here load collector I am going to use the EIGRL. What is EIGRL? That is a kind of a card image. It is used for normal mode analysis or frequency analysis, natural frequency, find out the natural frequency, and the here card image we have to take EIGRL. And in the other analysis, what load collector, force and SPC was there. Okay, were there. So that instead of that, we have to use the EIGRL. This is picking up because of last time I have used same. That's why it is just before the practical I have analyzed this problem. That's why the old data is directly taking from my old analysis. That's why it is showing directly here. Otherwise, here it would be no card image, and here maybe SPC. So likewise we are doing, but now here you have to use EIGRL, and here we have to set the card image. Basically, we are not using this card image for SPC and force. Okay, so this is EIGRL. Created it, not go for create. Created it. It will ask first frequency, last frequency, and number of modes. So at what frequency range that should be analyzed, that range we have to define here. So initial frequency we have to put 1, and the final frequency we have to put 1000, and in between that we require 10 modes. 10 modes. Modes means what? I will show you at the time of result. Okay, so this is what the mode means, that structure is going to displace according to that. Okay, in different directions. Or you might have seen that different modes in theory of machine laboratory, right? That shaft analysis, shaft that you might have solved one, conducted one experiment now on shaft. So that different modes, 3 modes we have observed, right? At that time, you might have remember. So here we have to 1000 and then return and 10 modes. Getting? Then next part, load collector. Then we have to go for the load steps analysis. Load steps. So here name should be pre analysis. And we are not going to use the SPC and other things. We have to use the method structure. So it is basically used for normal mode, means here not linear static. We require to use the normal modes. Modal analysis, for modal analysis we require to use the normal modes, means in the modal analysis you will get the natural frequency. Okay, so normal modes, method structure, and that method structure should be assigned with EIGRL card image. Okay, and then create it. So this is same step for all kind of modal analysis. Okay, model analysis, pre analysis. So load step is created. Now this we have to solve for OptiStruct by using OptiStruct. Then I will save this file in different one. Go to this PC, then D part, HM, 1D. I'll create this one. Roll cage structure. Enter. Roll cage HML save. Okay, and then here custom analysis and memory default. These three. Rishikesh, you check out that you morning you discuss one problem that Hyperview is not showing. So you just check out these three options. Here should be custom. Then here should be not optimization. Here should be analysis, and here memory default. If three options are there, then and then only it is possible to store the results. Okay, and then go for the OptiStruct. So here analysis is completed. Close it and go for the Hyperview then. Getting? So here we have to check out the different modes here. So go for this one. This one contours. Then hygiene mode, because this is a hygiene mode problem. So hygiene mode and apply. So you can see how here this is the first mode and the natural frequency is there. This one frequency 8.77 e raised to 10 raised to 1. So this is first mode, and we have to check out whether that roll cage is going to break somewhere, whether we have connected properly with all elements, whatever the elements we have selected. And if it is not breaking, then your analysis is correct or your modeling is correct. So I will play this one. So it is going to move like this. Even I can increase the value here. So you have to check out. It is too high. So you have to check out if my roll cage is not properly connected, it may be breaked at any corner, but it is not breaking. Means this front part is going to break like this. So this is first mode, right? We have taken 10 modes. So I will use second mode. So mode you will get here. Mode, first frequency. Here you will get the second mode, second frequency. So this is what the mode. Mode means that are going to be displaced in different direction. Okay, so this is what the second mode in this direction. Okay, so that third mode you can look at here, this one and this one. Getting third mode, then fourth mode. So this is a pre-condition. We have not applied load anywhere. So you will get this one natural frequencies at different modes. And the first one is the fundamental frequency. For first mode, you will get the fundamental frequency. Then here 5, mode number 5. So each and every mode we have to check, and we have to check whether that chassis is going to, roll cage is going to break anywhere. That we need to check out here. Then 6-1, this one. Okay. Then 7th one. Then this 8th one. Then this 9th one. And the last one, 10th one. Okay, so this analysis is perfect. Whatever, that not analysis, I will say. The modeling is perfect, I will say here. Then I will again go for the first mode itself. even though if I take it fast. So you can increase the speed or you can decrease the speed. You can record this by recording video. You can make the video. You can take the screenshot, snaps of this one. Okay. So this is how that required to do the model analysis. So one kind of analysis we can complete. So you can use one of the analysis as a model analysis, and you can solve this particular roll cage for the precondition. Getting? If you have any doubt, query, you can free to ask. Yes, am I audible? Rushikesh, Udesh.
Yes, sir.
Yes. Okay, so understood. It's very difficult to remember all the steps simultaneously, but I have recorded this video, so I can upload it and you can use that video, even though one link I also provided here. So this link, on this link you will get this problem, similar problem on YouTube. Otherwise, I will upload whatever my recording here on the Moodle, so you can download it from Moodle. So I will stop the recording right now here.